This video is on coordinate geometry, plane shapes. Before we get into coordinate geometry, we have to be able to mark geometry diagrams. We have to know what the symbols mean and also what the markings mean. So a couple of the things we have to utilize in coordinate geometry is congruency, lines are parallel, or lines are perpendicular. These are the three most important things to determine what type of plane shape we have based off of the properties of those shapes. So the first thing we're going to look at is to show that two line segments are congruent. Now congruent means the same shape and same size. The symbol for congruency is an equal sign with the tilde above it, because the equals means the same size, and then the tilde above it, the squiggle, shows us that they are the same shape. So on a graph, congruent sides have the same distance. So we want to show that the congruency, the equal size, which is the same distance, and then also the same shape. So that way they are both lines. That's how we know that they would be congruent. They are the same shape and same size. Now on a picture, the markings, if I were to look at two line segments, so I'm going to draw two line segments. And the markings to show that the segments are congruent are tick marks. So I can have one tick mark and one tick mark. That means that these two shapes are congruent. Now, if I have two tick marks on one and one on another, these are not congruent. So in order for them to be congruent, they have to have the same amount of tick marks. So I'm going to put 2 on both of them to show that they are congruent. And again, congruent means, I'm going to write this up here, same shape and same size. These are both line segments, so they are the same shape, and the same size are marked with the tick marks. The reason we use markings is because we don't always know the actual length, the distance between point A to point B. So if we're looking at just a diagram, we have markings. If we're looking at a graph itself, we can see the actual distance and we can use the numbers. The next important piece is to show that two lines are parallel. The symbol for parallel are two parallel lines, almost kind of like an 11. This is the symbol for parallel. So on a graph, parallel sides have the same slope. So we're going to find distance and we're going to find slope. Those are the two pieces of math we're going to have to use. So for lines on a graph where we can actually use the numbers, we can find the actual slope. But what if we are just looking at a picture and not on a graph and we just have the shape itself? We will have two lines. I'll just draw two lines here. Now they might not look parallel. Now remember, parallel lines are lines that never intersect, so they will be side by side forever. But sometimes you might not be able to draw well, or sometimes the shape is not drawn to scale. So how do we mark it? Just like with congruency, we have markings on the shape itself. So to show these two lines are parallel, we use arrows on the line itself. So I have one arrow on this line, so that means I need to have one arrow on that line. And it's the same concept. The amount of arrows have to match as well. So if I had 2 and 1, they would not be parallel. Just like 2 and 1 ticks would not be congruent. The amount of lines and the amount of tick marks and the amount of arrows tell you important information as well. And the last one we really want to look at is to show that two lines are perpendicular. So the symbol for perpendicular is an upside down T. Because what perpendicular does, it forms right angles, and we would have a right angle in this corner. That's why that shape is the symbol for perpendicular. So on a graph, perpendicular sides have opposite reciprocal slopes. So on a graph, we can actually utilize the numbers and find the slope again. So again, we're just using distance, slope, and slope. And we have to analyze the information that we get from that math. So opposite reciprocal slopes are perpendicular. These form right angles, which is why this symbol, again, for perpendicular is the upside down T, because it creates these two right angles in the corners. What if we do not have, again, on a graph, what if we just have the picture? I'm going to put our two lines that should be perpendicular. Perpendicular lines will cross each other or touch each other, unlike parallel. So they do have to touch and intersect to actually form those right angles. So if I have two lines intersecting, so I'm going to draw these two lines. Now, how do I show that they are perpendicular? The markings have to be there, just like the congruent, just like the parallel. I have to have a marking to actually show that these are perpendicular. And to show that these are perpendicular, I would have a right angle marking, which is a square in one of the corners. This is the marking that must be there to show that they are perpendicular. If you do not see this marking, then they are not perpendicular. It might look like they are, but if they do not have the markings, it is not accurate. So the markings are for shapes when we are not on a coordinate grid and we just have the picture. We have the distance and slopes when we are on a coordinate grid, because then we can actually find the values of the distance and the slope to analyze the differences or the similarities between them. So how do we find the distance or the slope? Distance, you're going to use the distance formula or the Pythagorean theorem on a graph. And that is Pythagorean theorem. I'm going to use Pythagorean theorem. It's a squared plus b squared equals c squared. But I know that in order to get the distance, I know I have to solve for c. So in the end, I know that I am technically going to be doing c is equal to the square root, because I have to get rid of the squared. So the inverse of squaring is square rooting. I'm going to square both sides. So I'll have a squared plus b squared. And that will be the math that I do. Remember, the a is the horizontal distance and the b is the vertical distance when we create our right triangle. For distance, again, you could use a distance formula, but the distance formula is derived from the Pythagorean theorem. The next thing we're also got to find is the slope. So remembering how to find slope says to use the slope formula or rise over run on the graph, which rise over run is the same thing as delta y over delta x. And I'm going to write that formula. Change in y, delta y, over change in x, which is delta x. So this is the important information that you have to use and have to find to be able to mark the diagrams, to find the distance and the slope, so that we can prove the properties that we're going to be utilizing.